Hi, Dr. Sunil Gadhwal welcomes you once again in online video lecture classes. Today we are going to discuss about domestic water purification or the purification of municipal water. So as in previous classes we had discussed about the sources of water and how water is getting contaminated. As we know that the rainwater in ideal condition is the purest form of water, but when it comes in contact with earth surface, it get contaminated by many chemicals during reaching to earth surface. In environment itself, it dissolves some poisonous gases like H2S, sulfur or oxides of nitrogen, CO2, carbon monoxides, and other gases which are present in atmosphere. So keeping these things in mind, also the municipal corporation has to purify the water before supplying in cities or big towns. So what are the, as we know that the drinking water must be transparent, tasteless, colorless, odorless, but free from all type of pathogenic or microorganism, hazard chemicals such as poisonous gases like H2S, lead, arsenic or chromium salts. So WHO had made a general guideline for drinking water that drinking water must have a pH range of 6.5 to 8.5, hardness less than 100 mg per liter CaCO3 equivalent, and total dissolved solids TDS must be less than 500 ppm. Water free from this characteristic is known as potable water or municipal water, and the whole process for making water free from the impurities and supply it to a consumer is known as municipal water supply. Next, purification of water. The type of treatment of water largely depends upon the quality of raw water. Usually water treatment for municipal supply consists of 5 steps like screening, sedimentation, coagulation, filtration and sterilization. So today in this class we are going to discuss in details about these steps, and hoping that you will understand the importance of the topic. This is very important topic from RTU examination point of view every year, and this is the only one big question from this unit. Every year it is asking in main exam as well as in back examination. So I would recommend to all the students that please you must cover this topic very well, and so that you can score well in the examination. So okay, let's start once again. So first step for purification of water municipal corporation is adopting is screening. So municipal corporation has to take the water from natural sources like river, lakes, reservoir, or whatever these sources, in a huge quantity, millions liters per day. Municipal corporation has to supply according to the need of the cities. So keeping all the quality aspect and the disease causing pathogenic microorganism and bacteria and all, municipal corporation has to purify before supplying the water, and also we ensure that the water whatever is in our home in the municipal corporation tap must be secure, safe for drinking point of view. So in screening so what municipal corporation is doing, they will take the water from all the reservoir in a big tank which has the capacity to supply a whole day in the city. So in this tank, in one side of this wall having some small holes or screen, steel, stainless steel screen, this one. So what they will do, they open this screen and water will come out from this holes. Because if we are taking water from rivers or canals, then that water having floating leaves, dead bodies, organic matters, slates, and also this screen will not allow this big particle to pass out from these holes. So they will trap here, and then municipal corporation, when this tank will empty, all the water will come out this side, they will remove this debris. Next step is sedimentation. Sedimentation is nothing but all this screen water we got from this first step. Municipal corporation will keep it in a large tank undisturbed for 6 to 8 hours, so that the big particles which are having high density due to gravitational force of earth, this high density particle will settle down on the tank, and the small particles which are less in density, they will not settle down. So for that, municipal corporation is adding some chemicals known as coagulant. So in the absence of coagulant, whatever the particles will settle down, that is known as plain sedimentation. But when we add some of the chemicals like alum or sodium aluminate or ferrous sulfate, then these will ionize. Suppose we are adding alum in the water. So alum, as we know, the chemical formula is potassium sulfate, aluminium sulfate, 24H2O. So when this alum will ionize, it will give aluminium hydroxide, a gelatinous substance. This gelatinous substance will trap these fine low density particles and force them to settle down the bottom of the tank. By this we can remove these small particles also. So third step is coagulation and flocculation. The theory of coagulation can be explained by following phenomena. Alum is to found the best coagulant and widely used in most of water treatment plants. When alum added to water, it hydrolyzes and forms a gelatinous, spongy white precipitate of aluminium hydroxide. This aluminium hydroxide will entrap the small or low density particles and force them to settle down the tank. Flocculation. The formation of floc is known as the flocculation. The efficiency of flocculation depends on the dose of coagulant mixing and the pH of water. Next step, filtration. The water coming out after the sedimentation and coagulation is still having small particles, so that also has to remove to make the TDS level less than 500 ppm. So for this removing process, municipal corporation adapting to filtration unit filters. Filtration units are two types. One is gravitational filter and second is pressure filter. So let's discuss about the gravitational filter. In this filter, water passes through the filter bed by gravity, and these are of two types. One is slow sand filter and second is rapid sand filter. As you can see in this diagram, this is this slow sand filter diagram. Here this is a one chamber. Here we are passing the sedimented water, and this tank will, the water level will go up and up and up, and from this all the water will enter into this sand filter. Here the top layer is of fine sand 3 feet around height, then a coastal sand around 1 foot height, and after that a gravel layer. And then here this is a screen where we are keeping gravels, then coastal sand, then fine sand. So this water come along with this wall slowly undisturbing this fine sand layer, and it will make a layer, and it is coming up, and this will fill up to this level. Then water, due to gravitational force, water will pass this fine sand, then coastal sand, and this gravels, and it will come here. From here we will take out the water. But this water is still has to remove. This is causing bacteria and microorganisms. After few time, when the filtration will stop, because this very fine particle will trap in this sand layer, and they stop the passing the water for this bed, then we have to stop the supply, and we scrape out this fine sand layer, and again we put a fresh fine sand, and then start again filtration. So this is the whole process of purification of the water. Now rapid sand filter. Rapid sand filter is nothing but just incorporated a pressure by passing high pressure air. So this is the same diagram. This way we are achieving in a cold chamber, a closed chamber. Here water is passed through this deflector plates. Deflector plates are having the property, they will allow water in one direction. So water will, after passing here, slowly it will come in this chamber. Then here is slimy layer of aluminum hydroxide, then fine sand, then coral sand, then pebbles. And as soon as we pass compressed air in this chamber, this air will put pressure on the water layer, and they will come out here fastly in comparison to slow sand filter, and we get here pure water. But this water still containing disease causing bacteria, microorganism, and all that we have to remove by doing other treatment, which we will discuss in the next class. Hoping that up to here you had understood. Thank you.